Hello everyone, this is me Abdul. So today we're going to be talking about packet capture, right? So basically, what is packet capture? So packet capture basically means um, you. What happens is sometimes for troubleshooting the network, you might want to intercept the packets, right, to figure out whether the network protocol you've implemented is actually working or not, right? So I implemented a very small, like low level network filtering program. I gave it a very nice interface, wrapped everything in a C++ class with a very nice interface so that allows you to sniff packets from the interfaces on the computer, right? So you have a choice. So let me and okay. So basically the whole program is goes this way, right? Okay. So let me save this, save that, yes. So if you look here, the whole program is like this, right? We included our header files, some important stuff for you. So this one, I wanted to keep it as close to pure C++ as possible. But then the library I'm using, which is the pickup library, packet capture pickup, right? It's implemented for C. So I have to like build my own wrappers, C++ wrappers for it, right? So here we have to declare from private variables. So here we declare, I created type aliases, right? So I typed alias the unsigned character pointer, constant unsigned character pointer to be the packet. So because your packet actually comes as a stream of unsigned character, and then what happens is you can treat your packet as sort of like a pointer. Then you can use that pointer to sort of get field by field the different parts of the packet, right? And then the net interface, we created an alias, type alias for the net interface. And also, we created an error buffer, right? So what happens is the pickup when you start it, right? It takes an error buffer, right? So that error buffer is used to by the pickup to store the error message when it tries to initialize itself, right? And then we have a BF program, right? So sometimes when you are running your filter program, right, you have to give a textual description of how or what sort of rules that your packets should use to filter the kind of packets you should catch, right? So what happens is it's sort of like a pipeline, right? So when your packets come in, right, there are sort of rules you can put, and that sort of rules, the kernels will use those sort of rules to sort your packets out, right? So that they match the rules, right? So you can see source host is equal to this, and to say that okay, whatever packet that's come, ensure that before you capture it, the source host or IP address of that packet is this specific value, right? So you have to have a filter program, right? So then we have the IP address. So the IP address, normally the way we see it is a dotted notation, right, of four integer values ranging from 0 to 255, right? But then those 0 to 255, right, you can collapse them into just an integer, right? So a 32-bit unsigned integer. So that's the IP address. And you have the net mask. Um, the net mask is more or less like, yeah, we'll explain that later. But the net mask has to do with specifying, I'll explain that later. Right. So we have the selected interface. So the there's a pointer that references our selected interface. So when we run our class, right, there is a pointer in our class that is used to like select an interface. So you can either select the interface by choosing from a menu, or you can select the interface by passing an argument. So we'll see that um, shortly. Then we have the live handle. So when you start the capture, right, you can specify a duration for which the capture should happen. Or if you put the value of 0, then it is forever, right? So pickup T stores the live handle. That is going to, because after you, when the class is being destroyed, you have to ensure that this live handle is destroyed, right? So you have to obtain a handle to that opened packet capture packet live handle, right? And then we have a function, so the callback function. So the callback function is of type pickup signature, right? So so let me open here slowly. Let me expand this one, right? Then let's oh no, okay, let me go down here. Okay, I should be seeing this. Okay, I should be seeing this. Um, okay, I want to see. Okay, good. So I want to see the workspace pane. Good. Sorry for keeping that waiting. Then we have the declarations, the HPP. So if you go to the declaration of HPP, we have a pickup signature. So the packet capture. So whatever packet is captured, right? Pickup implements a way you can hook, right? So what happens is there is a pipeline where you can place a function such that when pickup captures the packet from the kernel, right, it passes the pointer to the packet and a certain information concerning the packet to a certain function that you call the callback function. So anytime that packet that matches your filter is captured, right, the processing is passed to that filter function of your choice. So that filter function has a sort of a signature, right? The signature is more or less like the specification for the return type and then the type of the arguments that's supposed to be passed to it, right? And then we have an implementation, right? It's pseudo. So pick up like it interacts with the kernel, so you need like elevated privileges. So first we have a pseudo function that checks if the person is elevated. If it's not elevated, it returns a false. If it's elevated, it returns a true, right? Then we implemented a pointer to functor, right? So what happens is pickup itself doesn't accept like std function, right? Std function is sort of like a functor, right? So you pass a signature to a function and you pass it a pointer to the function with the specific signature, and then you can use the braces operator which is overloaded on the std function to call the function, right? So it's a sort of a function object. We don't want that, right? The pickup, as I said, is implemented in C, so we have to pass it like function pointers. So we have to find a way to convert the pointer to a function and back when we need it, right? So that's what we implemented here, right? So ip.hpp, not important for this setting. So that's it. So if you go back to the top, so that's our pickup signature. So the pickup signature is of the specification we specified earlier, and then we set it to null because it's not pointing to anything valid, right? It's not callable, right? It's pointing to an invalid function pointer. Then we implemented a throw error function. The throw error function is supposed to throw an error, and what it does is it gets the error buffer. So it checks the live handle to check if there's an error, and then it gets an error and copies the error to our error buffer. This error buffer of ours, right? It copies the error it gets into that error buffer and throws the error as an exception, right? And then sometimes you also want to capture all the interfaces. So anytime you run the pickup, it allows you to search the whole system for available network interfaces. So you have the N33, you have the LO, you have the loopback interface, right? You have the any interface, right? So you have the Ethernet interface that allows you to communicate over the Ethernet protocol, and then we have the loopback interface that's just like a local host. Then we have um, 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 then we have the Wi-Fi interface, right? That allows you to connect to the Wi-Fi card and then sniff packets on that interface. And we have the any. So the any represents all different types of interfaces. And now remember, some of these interfaces are software interfaces. So they might not be real network interfaces. They might be just software drivers that may make a network interface. So for example, some VPNs, right? in order to be able to redirect traffic, some firewalls in order to be able to protect you and redirect traffic. When you launch them for the first time, right, they create a device driver that they inject into the kernel, right? So they require elevated, they inject to the kernel, and this driver is hooked along one of the pipelines of the kernel packet processing routines, right? So that anytime that application is launched, it activates the kernel, that device driver, and it uses that to intercept and block packets along the packet processing pipeline of the kernel, right? So they pick up. So it's not every interface that is a hardware-based interface. There might be interfaces that are being used by different types of software, for example, firewalls, etc., to enable packet filtration in terms of protection, like protecting your computer, right? So we have to get all the interface. So we get um, a, a, a double character pointer, right, to a pickup if t object, and then our pickup find dev just picks everything from it, right, and then it returns a linked list of interfaces, right? So the linked list of interfaces starts with a head node, and then you pick the head node. Then every head node has a next, right? The next contains a reference to the next interface discovered till you encounter the null pointer. So that will tell you the end of the list of interfaces it was able to find, right? So it returns a linked list of interface. So pick up if t pointer of all devs is actually a linked list. So it's a pointer to a linked list of nodes, right? And those nodes represent data concerning a single device, a single interface device that the pickup was able to capture from your computer. So the string input, this one a simple function. It takes a prompt, it prints out and expresses an input, converts the input to a string and returns the value. So we need it. So, and also we have list interface. List interfaces takes all the interface pointers and then copies them one by one into a vector of net interface pointers, right? So the net interface is a type alias to the pickup if t, right? I did it basically for declaration of intent, right? So it's a vector to pointers of interface. So now sometimes anytime we want to access a single element in the loop, we have to always go through the linked list of all devices, right? And then compare the name so that we can extract the interface choice of our choice. But I don't want that to be the case. So I decided to package everything and separate each of the pointers and then store them in a vector so that it's easier for us to process. Then the display interfaces, you pass it a vector of interface list, and then it prints each of the interfaces, right? It prints the name, the description, and the flags, right? So the name basically is the name, like the name that is assigned by the operating system to that interface of your choice. And we have the description. So the description is a small message like of the type of, so for example, maybe if it's a loopback interface, see something like loopback interface, and if it's like an Ethernet if it's an Ethernet this thing, you can see some description of what it does, right? Some places don't have, so you realize that there's a small if I've placed there, right? So if the description is a null pointer, meaning that there's no description passed, then return an empty string. But then if there is a description passed, then return the description, a pointer to the description. And then the flags, right? The flags are some special, I still have not understood it exactly, but they are sort of has to do with some extra information you want to know about that specific device, right? And then we close it off. So for every device that's recovered in the vector of interface lists, it prints them in a very nicely formatted way. And then select interface, right? So select interface basically uses the two functions above to generate a nice menu, and then it allows you to choose to select a choice, right, from the interfaces that is passed to you. So the display interfaces displays the information nicely, and then it allows you to enter an input so that you, and then converts the input to an integer, right? And then it does some comparison. Then if it gets a valid index for one of the devices listed, right, it will to return the pointer to that device, right? And then we have a find interface, right? So the find interface, right, it's an implementation that I provided so that instead of you having to search on all the interfaces, you can just provide a vector of interface pointers, and then a predicate function that is supposed to match the interface of your choice. So sometimes you don't want to maybe only match the name, you probably want to match the name and the flag, right? So probably you want a loopback interface bar. You want a software device driver. So you have multiple of those software device drivers, but then you have they are unique by their flag. So maybe you might not only want to check by name, but also want to check by the flag field of the pickup interface pointers, right? So you can pass a predicate. The predicate should take a constant pointer to pickup interface because we don't want to modify whatever our pointer is pointing to, and it must return a bool, right? And then if it finds one, it returns an optional with the value of the interface pointer. If it doesn't find one, it returns a null optional, right? So we have only one constructor right now. We have only one constructor, and it is the default constructor, and all it does is anytime we start it, it initializes the buffer, right, that we allocated in the beginning as our error buffer to 0, right? So choose interface. So the choose interface, you can pass it an optional IF name. If this IF name is empty, right, this one will be better this way, exactly. So if this IF name is empty in the sense that it's a empty string, then it will allow you to select the interfaces from the list of interfaces listed. But then if it is not empty, then it will go through the process of trying to find the name you've passed it to, and then get the interface, right? So it searches through your interface and returns a value with the same name, right? And then so there's some check that is done here, but basically it checks if the thing has a value. So if it doesn't find your interface of choice, right? So here what it does is it lists all the interfaces, right? Returns this as a vector of interface pointers instead of a linked list of interface pointers. Then it returns an interface optional, right? So that interface optional, right, has to match it by name, right, which is the name of the interface you passed. And then if it finds one, this iFace.hasValue will return a true, right? So this first check will fail, but then if it doesn't have a value, it will return a false, right? Then it is selected iFace is equal to iFace.value, right? So we have a set callback function. So the set callback function takes an std function pointer, and it takes it by reference, right? And it should be a callback. So this callback, right, is the function that will pass our captured packets to. So when you set your filter, that's the filter is the program that specifies which criteria we should use to get which packet. So it's not every packet you might want to filter, right? There are only specific packets that match some specific requirements of yours. So when you filter the packet, the callback that will be called, right, when one of the packet that matches your this thing is met, right, is passed. So that callback is what you call the set callback, right? So we define some extra stuff. So you convert a struct adder to uint32. So sometimes you pass in a socket adder, well, which is a structure that is used by the Linux networking C runtime, C++ runtime, whatever, right? And it converts it to a 32-bit integer, right? So do some checks there, right? That's not important first now because we will not use it a lot. So we have the set filter. So the set filter, it takes a string of a constant reference to a string, which is a filter program, and then it opens a live filter with a selected interface name, right? If the right, and then there is 65,536. So there is a duration, right, that your so there's a duration that your how do I explain that? Your callback function to wait between calls to the callback function, right? So that's the maximum size of the packets allowed. So we specified 65,536 bytes so that we ensure that we can take different packets of varying sizes. Then you can pass a flag, right? Open flag promiscuous, right? So this means that pickup should sniff every packet on the interface, because remember, not every packet that comes to your interface is meant for your computer, right? So for example, for the Wi-Fi interface, when you are connected to a Wi-Fi network, right, the router in the Wi-Fi network has to make sure that it synchronizes addresses, right? So it has to make sure that, okay, when one person wants to send to another person whose MAC address it doesn't have, then there is a protocol that is used for identification of devices, right? So that if I don't have your MAC address, then the router can send a broadcast packet to every device on the, we call the app broadcast packet, for every device on the network. And then the device whose IP addresses match the IP address that we provided will return a response called an app reply with its MAC address embedded in it as the source MAC address, right? So this, there might be packets that comes to your device that might not be meant for your device. So the packet processing pipeline tends to ignore packets that doesn't belong to the device. But then to be able to perform promiscuous packet sniffing, then you have to make sure, right? So promiscuous packet sniffing basically says that, like, sniff all packets on my interface, whether it matches my details or not, right? And then it takes some duration, right? So 1,000 milliseconds, right? And then error buffer, right? Which is like when stuff go wrong, and then how should we get the error, right? So if the live handle is a null pointer, then that means that we weren't able to open the live handle because of some error in the values we passed. So it should throw an error. Then we have pickup lookup net, right? So we have to pick information of our computer, right? So we have to pick our computer's IP, we have to pick our computer's net mask, right? So subnet mask, right? And we passed, and then if it returns pickup error, that means that you should throw an error, means that something has happened, right? So pickup lookup net just queries our low-level system to determine our personal IP address and our subnet mask, right? Then pickup compile takes the packet filter program, right? And then it tries to convert it to a packet filter program. So you see this filter program, we did some BPF program, right? So it takes this textual string and converts it to a certain value that they can pass, then can be passed to the kernel packet filtering processing pipeline to ensure that it can use that to be able to filter packets based on whatever you've provided. When it's an empty string or a null pointer, nothing happens, right? Then here it passes the net IP, right? The network IP, and then the network mask. Now, if it fails to compile because of an error, right, it returns pickup error. So we compare to pickup error. Then if that's the case, then we throw an error. Then it now sets the filter. So after it's able to successfully get the filter program by compiling it, we then set the filter on the live handle, because the live handle is where our capture is going to go, right? And if it fails that one too, we throw an error. Then we have the run function. So the run function first checks if the live handle is null, meaning that we weren't able to open it because we are not in control, right? The user can call live handle at any point the user wants. We don't want that to be the case. So when the person calls live handle on a null pointer, then we try to tell him that, okay, you are doing something wrong, right? There are no open handles. So you first have to open a handle and set the filter, right? And then we have the function pointer, right? So the function pointer is going to, so this value is going to retrieve the value of the function pointer from the function object, because std function is a wrapper on top of a function, like a native function. So a native function is just like a pointer to a section in code memory in the text segment of your like running program, right? So you might want not to get the function object itself that holds the pointer to that memory location, but then get a pointer to the memory location of the function that you have to actually call, right? So we have to retrieve that pointer out. Then it first checks to see if that pointer is null, print pointer is null. This one was for debugging purposes. And then if that one is satisfied, then it goes to pick up loop. So this is where the loop starts to run, right? So you can give it a duration to run, right? So maybe like run it for 1,000 seconds, run it 2,000 seconds, right? But then run it for a certain amount of time. Now, if you pass a 0 to it or a negative number, then it will imply that you want it to run for forever, right? Yes. And then we have a virtual distractor. When it fails, when the class is being destroyed, it has to close the live handle, right? So it will close it here, right? So that's basically the entire structure. So let's go and see our C source file. So we have a handler here. All it does is it picks the packet capture length and also picks um, the time, right? And then print something to the just to ensure that our handler is being called, right? So we say pick up packet sniffer P, then we p.choose interface. So if you do p.choose interface with an interface name, it will automatically search and then choose the interface of your choice. If you don't put an interface name, it's not gonna search. It's gonna bring you up a menu, and then you can choose the interface, right? So, and then here we have to convert our function pointer into a std function, right? And then we have to set our callback, right? So p.set callback to our packet handler. Then we set our filter. So we want to filter all packets whose source host, that's their IP address, right? The source IP address of the packet is 142.250.191.110, right? And then p.run. So you should run it for 1,000 seconds, right? A couple of minutes. So let's see our program in action. So let's open our document. So we have our ping running here. It has been running forever, and then you can see that there's a we make a ping, right? So the ping sends a ping message to whatever IP address you provided, and then that IP address will respond. So we are saying that when it responds, then if the source IP address is whatever matches whatever we've given, then filter by that, right? And then yes, so if you go here, make run, it's running, it's compiling. So it's asking me for a password because administrator privileges, right? So you can see that the capture is happening and it's printing to the screen, right? Now you could see here it didn't ask us to choose anything, right? It didn't ask us for a menu, right? It automatically chose it for, because when we invoked the choose interface on the packet sniffer object, right? We passed a valid interface to it, which is the any interface, right? So what if you don't want to do that? Let's change, right? Let's change and move this one aside a little bit, and let's come here. So let's put in an empty string, or let's leave here empty totally, right? Meaning that we want you to pass us some menu, right? Oh, it's supposed to pass us a menu. Okay, I'm coming. That's strange. Okay, I'm coming. Let's check our code and let's do some live debugging. Follow along with me. Okay. So the run here, right? Let's go here. Okay. Let's go here. So we have where we let's go down here. Go up, 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 up. So go down. Right. So the choose interface IF name. Okay, if IF name is null, if it's empty, then like give us a chance to select an interface, right? So you calls the select interface method, which is here, right? Select interface. So the select interface prints everything nicely for us. I don't know why this case is not working. For some reason. Okay, let me save here. Let's go back to here, and then let's call it again. Good, now it's come. I think I didn't save it, so let me that one slightly this way, right? Move this one slightly here. Let's watch the two in action. So you can see here it emitted a terminal of available devices. So the available devices, we have the device name and straight away it has no description. The flags is 0x16, and as I said, the flags mean something. I didn't have time to do so much research on the device. Then we have the any, right? So you see here it's a so device that capture all interface. So it's not really a real device driver. It's just a device driver where every data coming from all the interfaces routes to, right? And then it has a flag of 0.63. So let's just say I want to choose on the right. I want to sniff packets on the any interface. So I can pass one, the any interface. So that's one, yes, right. Now if I pass values that are out of range, right, it will check and say, okay, I have to choose within range. So it will not allow me. So let's just see. I'm going to put the right value, which is 1, and then to start capturing. Did you see that? So when you pass it an empty string, right, it means that you don't want to specify any value. It should list all the interfaces for you so that you will choose. But then if you want to pass your own interface, then you can pass it as a string into the pickup choose interface object, and then it will execute it for you. Right, so basically that's the entirety of my project. Thank you very much for listening. If you have any comments, please pass them down. I'll be very happy to get your feedback on what I just did. And if you want any special tutorials on C++, sideways tutorials, you want me to teach you C++, I'm available. Right, my email is on my LinkedIn profile, and I'll be glad to hear from all of you. Thank you very much.